Right then. So, as you're probably all aware, everything's getting more expensive, budget's getting tighter. On the railway, we're seeing increasing demands for maintenance and improvements. We then have the government carbon zero challenge, which adds significant considerations to how we plan and design our work. So, my challenge is how do we make the railway more sustainable, getting those funds to go further while reducing carbon and timescales to deliver the projects we need. Does it? Yeah. So one such project we're calling Better Value Footbridges, where we're looking at our station bridges for accessible use. We want to reduce the carbon footprint by 50%, whilst reducing the cost by a third, and doing this all a lot quicker than it normally takes, down to 12 months from having the budget to having something delivered, and all the time trying to minimise the disruption to the passengers and the trains. So one such project I'm looking at is for non-station bridges. This one's at a level crossing, and how do we make our crossing safer with a bridge solution? And this is our standard design, which is a steel, very heavy, very high carbon footprinted, very expensive steel solution, which is quite dated and no one wants it anymore. So it's making it harder to close crossings. So in 2020, I got some R&D funding, and my aim was to develop a low-cost, lightweight footbridge. The more crossings we close with a cheaper solution, the more we make the railway safer and operate quicker. What I also wanted was something transformational, taking us into the 21st century, showing what can be done. And I also wanted to incorporate intelligence into the bridge so that we could evolve and make them better. To do that, I chose to do things differently. So we just hit COVID when I started, but I managed to amalgamate a small team of UK-based small medium enterprises who we judged on their advocacy, willing to change. They weren't bridge designers, they hadn't worked on the railway, most of them, yet they demonstrated the skills and the capability that would enable me to produce something different. And this is what we came up with in June 2020. You can see it's an evolution of our standard footbridge shapes, but it's got a few radical things. We got a different form of construction with a structural backbone and deck units fixing to it. We're embracing modern methods of manufacturing, but we wanted to make it a lovely experience for people to use, so it felt safe and a part of your journey rather than a blocker. And we thought, can we make this into a modular suite of designs, which then covers as many locations and challenges as we face on the railway? So you can see it's sort of an evolution that you have straight units are the same, and we just have two curves, handed curves, and that gives you many configurations. But also, if you attach lifts to it, can you address the station challenge of the better value footbridges? And then you can look at ramps as well. And this is what we wanted to produce. So this is our architectural image. We wanted a wow factor, but also we want to make it a sort of bridge fit for here and now and the future. So it's glass parapets for visibility, for safety of people going onto the bridge, using the bridge, as well as seeing the environment, whilst minimizing the visual impact to the community that it serves. And this shows how it goes together. So it's a box of components, small components. You've got the structural spine, which is a primary load-bearing element, onto which you drop and fix the deck units, which then enhance the capability. They work in conjunction. And because we've got small components, it means that you can build it in stages. It's always safe, so it fits in with the railway constraints. And we built a test one on a test track. Then we took it down, put it in the shed, played with it, and then we put it on the railway at this location in Shropshire. And that image shows you the foundations. So we could use something called Rapid Route, which was hand-driven by a team of 4 people in 3.5 days with minimum disruption, unlike a concrete footing or big piles. which was all part of the ethos of cheaper, quicker. And then we got the spine. So this is the main structural support. It was spanning over 3 tracks, 23 meters span from bottom of the stairs to the other side of the bottom of the stairs was 54 meters, yet it only weighed 2.5 tons, made out of fiber reinforced polymer. The brown color is because we use flax fibers on an outer coat to understand how biomaterials worked and performed. And then we got those deck units going on. So we set a weight limit of 2.5 tons per unit. So we could use small road rail plant, as you can see there. And they were just dropped on in stages. So we built half of them in one night, left it. It was all very safe. And then we came along and finished it the second night. So you could work around the railway constraints. And that's how it looked. So that was last year, last January. As you remember, the image I showed of what we wanted to build is as close as we could get it. It's a very open bridge. That's the locals enjoying it because you can see the environment you're in. It was as true to form as we could get. And now we are in the stage of developing the production version so we can roll it out and meet all the cost and carbon challenges that we need to. And just some headline figures. So as I said, we were working through COVID. In 11 months from that concept, we had one designed, manufactured and built. It was half the weight of a steel bridge of equivalent span, yet we're projecting 40% project cost reduction. We're aiming for that 50% in the manufactured version, and we think we can build one of these in 2 weeks rather than 3 months of a steel bridge program, and it has monitoring in it. So just some follow-on information if you want. There's a couple of articles about the flow bridge, the opening, and then a page on our website with a bit more detail. I've also put in a bit about our buildings and architecture's design manual, showing how forward-looking we are trying to be in this company. And then finally, we got challenge statements in Network Rail of some of the problems we face that we need some great ideas to try and solve. Okay, so hopefully that's it. And over to FA now.
Hello, everyone. Today I'll be talking about the key research themes we have at Arup and a bit of background information about myself. I am in the research team that manages centrally the different types of research projects we have in Arup. Arup is a quite interdisciplinary firm, so we get projects from 60 different disciplines, often interdisciplinary projects. So it's going to be exciting to run through some of the key themes we have. So research is essential for Arup or any stakeholder in the industry to remain competitive and innovative. This applies to multiple types of stakeholders, and obviously a big part of our work comes through collaborating with different types of organizations. But it's worth saying that we invested about 4 million in research projects in the last financial year. And a split of those projects, about 230 of those projects, they've been split across 6 themes we have identified. These themes become quite relevant for these interdisciplinary types of work. They are creating inclusive places and communities, enabling restorative and regenerative design, delivering nature positive outcomes, utilizing data-driven and digital solutions, shaping resilient systems, and transitioning to net zero carbon. To go a bit deeper into transitioning to net zero carbon, this is particularly looking at how new pathways can be developed to decarbonize. Obviously, so you can see some of the examples down there, ranging from social sciences to very technical engineering things as well, new economic models to having new technologies of carbon capture. So one of the examples we have in this area is a quite important research conglomeration we've got, which is on data-driven methods of construction. This is particularly a research in collaboration with TU Darmstadt, and it's exploring how robotics is changing the nickel sulfide inclusion standards in the industry. So, yeah. Another theme is the resilient systems one, and this is brings a bit more of systems thinking into having a holistic approach to our research projects. Um, you can see things around climate risks or any disaster risks in general, but you can see things that are not necessarily disaster related, but have future supply chain developments or next generation materials. An example here is the state-of-the-art high-resolution weather simulations we have with UCL, University College London, and Reading University. This is particularly looking at how urban heat islands behave in certain contexts, and it has been later used to consult and help with the UK government's, both at a local and a national level, the policies they have towards urban heat islands. So. Yeah. Another theme is restorative and regenerative design. Again, you'll see some novel approaches here that particularly focus at how regen works in the built environment. This again, I mean, you can see some overlaps between these themes, but to distinguish this one, it's probably worth noting that the reuse and the repurposing and the retrofitting of our currently existing assets comes up as a quite relevant topic here. And another example here is a multi-year research project that is looking at how CLT can be used in high-rise buildings. It's still a work under progress, but it's already influenced some codes across national and international standards. And yeah, this is one of the more interesting projects we have in the fire research. So yeah. One more theme is on inclusive places and communities. This is when we go to more intangible and social sciences based probably themes that we have, and obviously you again have an intersection of hard engineering with softer areas like role of lighting, for instance, in enabling inclusive cities for women and children is super relevant, and housing and unemployment in the city come up here often as well. Um, an interesting one we have is on how to deliver medical care in remote parts of Scotland. This is working in collaboration with NASA and the NHS. And in particular, this project brings engineering solutions to a social issue where people with less access to healthcare can benefit more from healthcare. We also have data-driven and digital solutions. I guess AI can be a part of this as well to a certain degree. And it looks at how the digital world can be utilized basically for further research. And you can see again, this has implications across multiple engineering sectors, but it can also be used for legislation and other social issues around the built environment. Thank you. We have a project in Australia, which is on accelerating future mobility with responsible technology and data governance. We work closely with the legislators there, Department of Transport and Planning in Victoria. We've helped them develop their digital strategy around the future of mobility. So yeah. And finally, we have nature positive outcomes, which is particularly focusing at nature-based solutions and nature-based services and how we can coexist with nature in our engineering through our engineering solutions. The hardcore engineering bits of this also often intersect with biology and naturalists' work. So there's a lot of interesting overlaps. It is one of the more interdisciplinary themes, probably. Therefore, it's becoming more and more relevant as time passes. The work around mycelium we have is often used as an example. mycelium or other types of nature-based solutions can be used for flood resilience. And restoration of wetlands is by indirect or direct means helping with resilience of flood protection. And we have applied this to Madagascar and South African clients. So yeah, if you have any further questions, please don't hesitate to reach out at research@art.com or my personal email as well. I'm from work. Yeah, any future research ideas or just have a chats would be very nice to hear from you. So thank you very much.